Welcome to the DIY Honda Garage channel. Welcome to this detailed troubleshooting guide for DTC P2123 related to the Accelerator Pedal Position APP Sensor A circuit in the Honda CR-V 2023 and newer models. DTC P2123 indicates that the output voltage from the APP Sensor A has exceeded a specified threshold, prompting the Powertrain Control Module (PCM) to recognize a fault and log this diagnostic trouble code. The APP sensor is integrated with the Accelerator Pedal Module, which plays a crucial role in determining the vehicle's throttle position, directly impacting engine performance and responsiveness. The PCM utilizes data from this sensor to manage fuel injection and ignition timing, thereby ensuring that the engine operates efficiently. Any disruption in the APP sensor's output voltage can lead to erratic driving behaviors or reduced engine power, making it essential to accurately diagnose and resolve this issue. This guide will walk you through the symptoms, causes, and specific troubleshooting steps to efficiently handle DTC P2123. The recorded error DTC P2123 relates directly to the Accelerator Pedal Position APP Sensor A, which serves as a throttle position indicator. This sensor is integrated into the Accelerator Pedal Module and is typically located in the driver's footwell, making it easily accessible for inspection. Its primary role is to send real-time throttle position data to the PCM, ensuring that the engine responds correctly to driver input. When the APP sensor detects a voltage output higher than the expected range, this information is communicated to the PCM, leading to the storage of error code P2123. Understanding the functionality of this sensor is critical to troubleshooting the vehicle's performance issues accurately. Ensuring that it operates within specified voltage levels is vital for smooth engine operation and drivability. Any malfunction in this component or its associated circuits can lead to serious performance issues, necessitating thorough diagnostic steps. Several potential causes can lead to the activation of DTC P2123, each requiring careful investigation. First, the APP sensor itself may be faulty or have internal issues that lead to excessive voltage readings. Secondly, wiring problems, such as short circuits or damage to the wires leading to the APP sensor, can also result in high voltage outputs. These wiring issues can cause electrical resistance or interference that affects the sensor's readings. The third possible cause is a malfunctioning Powertrain Control Module, PCM, which may not process the sensor's input correctly, leading to erroneous voltage signals being recorded. Lastly, electrical interference from nearby components or devices can distort voltage levels. Identifying the exact cause will require a systematic approach, evaluating each potential area to determine where the fault lies. There are several symptoms associated with DTC P2123, which can indicate issues with the vehicle's acceleration and overall performance. The most immediate sign is the illumination of the check engine light on the dashboard, alerting the driver that a fault has been detected. Following this, drivers may notice erratic throttle responses, where the engine does not react consistently to accelerator input. This inconsistency can be dangerous, especially in situations requiring controlled acceleration. Additionally, a significant reduction in engine power may occur, making it difficult to drive the vehicle efficiently. In severe cases, the accelerator pedal may become unresponsive, posing a safety risk while driving. Being aware of these symptoms can help drivers take necessary precautions and seek repair services promptly before further issues arise. The first troubleshooting step is to turn the vehicle's ignition to the on mode and check the APP sensor A voltage using a diagnostic tool such as the HDS, Honda Diagnostic System. This tool allows you to monitor real-time data from the vehicle's sensors. You need to verify that the APP sensor A voltage does not exceed 4.9 volts. If the reading is above this threshold, it indicates that the failure has been duplicated. Confirming the presence of the DTC P2123. It is essential to ensure accurate readings at this stage, as any discrepancy could lead to misdiagnosis. If the voltage is found to be normal, further inspections will be necessary to identify other causes of the issue. Properly executing this step is crucial in guiding subsequent troubleshooting efforts toward pinpointing the exact source of the problem. In the second troubleshooting step, you will need to disconnect the APP sensor connector, which has 6 pins. This will allow for a more thorough inspection of the sensor's output voltage. After disconnection, you should test the voltage output while the ignition is in the on position. The expected normal output voltage level from the sensor should be approximately 5.0 volts. If the reading meets this specification, the APP sensor module might be functioning correctly, suggesting that the problem lies elsewhere in the electrical circuit. However, if the output is abnormal, it indicates that the APP sensor may be defective, necessitating further evaluation or replacement. This step is crucial to establishing whether the APP sensor is at fault or if the issue is related to other components in the circuit. The third step involves conducting an SG1 open wire inspection. First, ensure that the APP sensor connector and the PCM connector are both disconnected. This step is necessary to ensure the accuracy of the testing process. With the connectors removed, measure the resistance of the wiring related to the SG1 circuit while the ignition is off. A healthy circuit should show a resistance of less than 1 ohm. If the resistance is higher, it indicates a potential break or fault in the wiring, which could cause inaccurate voltage readings and result in the DTC P2123 being stored. This step is crucial because it eliminates the wiring as a potential cause of the issue and helps focus on replacing any damaged components. Properly checking the integrity of the wiring ensures the reliability of the electrical signals between the APP sensor and the PCM. The final troubleshooting step focuses on inspecting the powertrain control module, PCM, for potential faults. If the previous inspection steps have indicated normal conditions for the APP sensor and wiring, it becomes necessary to examine the PCM's functionality. First, confirm that all other related components and circuits are operating within specified parameters. If any irregularities are found during previous diagnostics, those will need to be addressed first. However, if all other components are functioning correctly and the issue persists, the PCM is likely the root cause of the problems being experienced. In this case, it is advisable to replace the PCM to restore proper function. Testing the PCM requires advanced diagnostic equipment, as it plays a crucial role in managing the vehicle's performance. Ensuring its operational integrity is vital for the smooth functioning of the entire automotive system. After completing the troubleshooting and addressing any identified issues, it's essential to verify that the repair was successful. Start by clearing any stored diagnostic trouble codes in the PCM using the HDS. Following this, take the vehicle on a test drive to ensure that it operates smoothly and that no symptoms of the previous issue, such as erratic throttle response or engine power loss, reappear. During the test drive, pay close attention to how the vehicle accelerates and responds to driver input. After the test, recheck for any returned DTCs using the diagnostic scanner. If no codes are reactivated and the vehicle exhibits normal driving behavior, it indicates that the problem has been resolved. This final verification process is crucial in ensuring the reliability and safety of the vehicle post-repair. It allows for reassurance that the underlying issue has been properly addressed without the recurrence of symptoms. Preventive maintenance is an essential part of ensuring the long-term reliability of the vehicle's electronic systems, including the APP sensor and PCM. Regular inspections of the APP sensor and associated wiring can help identify potential issues before they escalate into more significant problems, such as those associated with DTC P2123. Keeping an eye on wiring integrity is vital, as frayed or broken wires can lead to incorrect voltage readings and operational inconsistencies. It is also wise to keep the PCM updated with the latest software revisions from Honda, as these updates can improve performance and address known issues. Regular maintenance can extend the lifespan of critical components and enhance overall vehicle functionality, reducing the likelihood of future diagnostic trouble codes from occurring. By implementing these preventive measures, vehicle owners can enjoy a more reliable and efficient driving experience. In conclusion, DTC P2123 signifies an issue with the Accelerator Pedal Position (APP) sensor, which is crucial for managing throttle response and vehicle performance. Understanding this diagnostic code, its implications, and the role of the APP sensor within the broader context of vehicle electronics is imperative for effective repairs. The systematic troubleshooting steps outlined in this guide can help accurately identify the root cause, whether it be the sensor itself, the associated wiring, or the PCM. As emphasized, addressing these issues promptly can prevent further complications or safety risks while driving. Furthermore, committing to preventive maintenance practices enhances reliability and durability of the vehicle's components. By adhering to these guidelines, vehicle owners can enjoy a smoother, more dependable driving experience in their Honda CR-V 2023 and newer models. Please like and subscribe to the channel. See you next time.